All right, so we're going to look at 2.3 multi-step equations. This is part B. Okay, oh, there it goes. Part B, this is a second part. Okay. Multi-steps, there are a lot of different types of multi-step equations. The first set we've learned were your basic two-step equations. So we take it, we want to move whatever is not attached to the variable. So we want to move our addition subtraction first, and then we move our multiplication division. Well, sometimes we don't always get to do it that way. And that's why I said, for the most part, it works this way. Sometimes we have to move things before we can do any multiplication or division. So again, 2.3 multi-step equations, part B. Remember, you don't have to write the goals. But again, this is just kind of give you an idea of what we're looking at. Again, we're not looking at consecutive integers. All right, so we're going to jump right into this stuff, and we're going to look at solving some examples. And this is a basic two-step equation here on the left. But the funny thing is that we have a fraction attached to our variable. Okay, so we have 2/3 x minus 25 equals negative 11. All right, so we want to take a look at this first one. This one, don't let the fraction throw you for a loop. Don't be like, oh my God, there's a fraction. I don't know how to do this. Just take it step by step. We have a number attached to a variable. So we have 2/3 times x minus 25. We need to get x by itself. So let's move the 25 to the other side of the equal sign. So remember, to do that, we need to do the inverse operation. So the 25 is negative. So we're going to add 25. Those go away. We're going to add 25 over here. Leaving me on the left side, we have 2/3 x equals, well, negative 11 plus 25. That would give us 14. Okay. Now, if we remember, how do we move? So if we have a fraction times a variable, we know we need to divide, but if you remember, dividing fractions is the same as multiplying by the reciprocal. So what's the reciprocal of 2/3? It's 3/2. So we're going to multiply both sides by 3/2. That makes these 3's cancel, these 2's cancel, leaving me with x here. And then we're going to multiply this side by 3/2 as well. But if you remember, all whole numbers are over 1. So if you have to, put 14 over 1 to help you out. We can cross cancel here. 14 is divisible by 2. It's 7. 2 is divisible by 2. It's 1. So now we're just left with 7 times 3. 7 times 3 is 21. 1 times 1 is 1. So it's 21 over 1, or 21. Okay. Again, you could plug this back in. You could take 21, plug it in for x, multiply it by 2/3, then subtract 25, and you should get negative 11. Now let's take a look at this one. This one, there's a lot of fractions going on here. I'm going to show you guys a cool little trick to get rid of fractions. So if you're dealing with, every piece has fractions in it. So the number being multiplied by the variable. We're adding and subtracting fractions. We have just a lot of fractions. We want to get rid of fractions. What you can do is you can take the whole thing and multiply it by the least common denominator. Again, here's that least common denominator coming into play. Well, here, our least common denominator happens to be 10. It happens to be the bigger of the number. So we're going to multiply everything by 10. We're going to distribute this 10 to everything in this equation. So 10 times 1/2, or 1/5. Okay, I'm going to write it over here. 10 over 1 times 1 over 5. Cross cancel 1. This turns into a 2. So 1/5 times 10 is just going to be 2x plus 10 times 7/10. Well, the 10s will cross cancel, leaving me with 7. And 10 times 9/10. The 10s will cross cancel, leaving me with a 9. So by multiplying by the least common denominator, I got rid of all fractions, and now I'm just left with this two-step equation with whole numbers. And we know how to solve these. So let's subtract 7. Subtract 7. 7's go away, leaving us with 2x equals 2. Then we divide both sides by 2. Divide by 2. Leaving us with x equals 1. Okay. So if we only see one fraction, so we see the fraction attached with the variable being multiplied by the variable, just follow your normal steps, then you can multiply by the reciprocal. If we see everything with a fraction, multiply the whole equation by the least common denominator. I'm going to give you a hint. The ones I'm going to give you is going to be the bigger number. Multiply by the least common denominator to everything. So you're distributing it, and it will get rid of the fractions. All right. All right, so what I want you guys to do is I want you to try these on your own. So remember, this first one, solve it normal, multiply by the reciprocal. The second one, you're going to want to multiply by the least common denominator. Hint, 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 it's going to be 12. To get rid of the fractions, then solve. All right, so I want you to try this on. So please pause your video now. So pause the video now. All right, so the first one, you should have gotten x equals 21. And the second one, again, you multiplied everything by 12. It would have then left you with 9m minus 1 equals 15. And then when you solved, you would have gotten m equals 16 over 9. I apologize, I meant to make this a whole number. But that's fine. 16 over 9 is an acceptable answer. You could plug 16 over 9 back into the original equation, and you would get to prove that it is true. All right. So remember, when we see a whole bunch of fractions, we want to multiply by the least common denominator, get rid of all your fractions. Then you have a basic, you're working with integers. If you just see one fraction being multiplied by the variable, then what you're going to do is you're going to follow your steps. In the end, multiply by your reciprocal. All right. Now the next step. Next set of multi-step equations is sometimes we have to tweak the rules a little bit. We've been working with getting rid of whatever's being added or subtracted to the variable. Sometimes we have to change it. So we have y plus 7 all over 9 equals 6. Here's another thing, kind of thinking of this as a fraction. When we see a problem like this, where we have a variable plus a number, or something times a variable plus a number, and it's all over a number, or you want to get rid of that fraction first. All right, so remember, all a fraction bar means is division. So rather than going, oh my God, it's a fraction, and panic, just think of this as division, and to get rid of division, we multiply. So we're going to multiply both sides by the denominator, because we want to get rid of that fraction quick. So multiply by the denominator. That's going to leave us with y plus 7 equals 6 times 9 is 54. Now we have a simple one-step equation. Subtract 7, subtract 7. These go away. Y equals 47. And again, you could plug in 47 back in for y. You get 47 plus 7, which would give you 54. 54 divided by 9 gives you the 6. Okay. Now we have this one. This one we can solve two different ways. All right. The first way I'm going to talk about is if we take a look, if we cover up equals 12, we just have distribution. So we can distribute this 2 all the way through. So now we have 2x minus 6 equals 12. Okay. That distributive property is coming back. Now if we take a look, simple two-step equation, let's add 6, 2x equals 18, divide by 2, x equals 9. Okay, that's one way you could solve this. The other way you could solve this is I'm going to rewrite this problem. The other way we can solve this, if you remember, distribution means multiplication. So what is the opposite of multiplication? The opposite of multiplication is division. So we could actually divide by 2, leaving us with x minus 3 equals 6 divided by 2 is, or 12 divided by 2 is 6. Boom, x equals 6. Now we have a one-step equation. Add 3, x equals 9. So we solved this equation 2 different ways and we got the same answer. All right, so we have a method 1 and we have a method 2. You could choose whatever one is easiest for you. If you understand the one where you divide, do that first. If you prefer the one you distribute, do that. Either method is correct. I'll give you a hint. If you're trying to divide and it's not working right, don't do the division first. That's why I showed you both of them. All right. Understand that sometimes you have to distribute before you can actually solve. All right, so knowing that, I want you to try these on your own. I tweaked them a little bit, but think about the different rules. And I put this on the other side. I'm going to give you a hint. That is a -3. -3. Make sure you distribute the -3. All right. All right, so pause your recording. Pause the video now so that you can try these on your own. So pause it now. All right, so if you solve these on your own, the left side, you should have gotten k equals 11. The trick here is when you move that 3, you'd end up with a -k. You got to get rid of that minus sign. So divide everything by a -1. End up with k equals 11. All right, and again, we can plug that 11 back in. And here, you should have gotten -14 equals y, or y equals -14. I did it where you divided first. You could have distributed. If you would have distributed your -3, you would have ended up with -3y minus 36. And then you would have added 36 and worked from there. So that's what you would have gotten if you would have distributed. And then you just solve from there and you should have ended up with -14 equals y, or y equals -14. So those are a couple different ways. Remember, if you see all these fractions, multiply by the least common denominator. All right. All right, remember, if you have any questions, put a star by a problem. If you want to see another problem, put a star by that problem as well.